Hi, my name is Caleb Sima. Welcome to my presentation on unlocking the future. AI is the key to top security challenges. So I hope to give you in this presentation actually a positive talk on AI and security versus what I think you're probably used to, which is a little bit of doom and gloom. There is no FUD in this presentation, and I hope when you walk away from this, you'll have a positive and optimistic outlook on how AI will help us in cybersecurity versus give us more problems to solve. So let's get started. In order for us to sort of think about what I'm going to do in this presentation, which I'm going to be giving a lot of, let's say, assumptions or predictions around how AI is going to help us, we need to understand at least a little bit of the basics of what AI fundamentals are first. So many of you probably by this point in time already understand a lot of this, but let's go over it. So AI, what is it good for versus also its limitations, sort of the strengths and limitations. The power of AI is sort of in its non-determinisms, but it's also a double-edged sword. So for example, when you look at what everyone complains about AI, it's about its ability to not be consistent, its accuracy, it has a lot of that repeatability challenge, and it's also limited in its memory, and obviously it's high cost and it can be slow. However, it has a lot of strengths. The strengths are obviously the reasoning and logic that you can get out of AI, the communication skills, synthesizing this information. We use it a lot in AI to, you write your emails, it can rewrite your documents, it can create entire structures and documents. It can help you think through strategy. It can come up with product ideas. It's interesting because its strength is a lot of creativity and artistic capability versus what most people thought of before AI came around, which it would just be about automation and robots. So for any of you who have used AI, to me, when I interact with AI and use it in its chat, my walk away and where the current state of AI is today is I sum it up in this quote, which I think that AI feels to me today, and it is a genius 13-year-old who clearly has a PhD and graduated with all sorts of intelligence, super smart, but is overconfident and with a very short attention span and no street smarts. So for those of you who have prompted or prompt engineering AI, this very much, I think, today is what AI is like. However, as we move further, every month that we move, I think AI becomes older and smarter. So if you look at where AI goes in a year or 2 years from now, you're definitely not going to be dealing with a 13-year-old. You're hopefully going to start dealing with a 20, 22-year-old who, yes, is still going to be overconfident, hopefully with a much longer attention span and much more street smarts. And this is how you start judging what I think a lot of people call AGI. Everyone says AI needs to get to AGI. AGI is really not judged on where there's a particular line, but more about the growth of where AI goes in terms of how it feels like when talking to them. So when you get to the point you're talking to a 35-year-old person who is super smart, very intelligent, and a lot of street smarts, and can understand the world around it, that is when you get to AGI. All right. So now that we kind of understand a little bit about AI, here is where I'm going to make some of my predictions. Now, it's important to understand sort of the predictions of where AI is going because in the future versions of this deck, I'm going to be telling you how AI is going to affect cybersecurity. And in order for us to get there, these things have to be true. So let's look at where we are today. So let's take the first thing, expanded context awareness. Now, what is context awareness? Under AI has a very sort of short window. So many of you may have read the news or seen talks about, you can have, a million token context window. And what that means is similar to humans, it's like your short-term memory. Right? If you are talking with someone, you can remember things very clearly in the moment that you're discussing that with them. So if we're talking and you give me a phone number, I can, oh, as soon as you say it, I can repeat it. I know it. It's my short-term memory. If you ask me about that phone number, say 10, 15 minutes later, I could repeat some of it, but I may be wrong on a digit or two. Ask me a day or two from now, and if I don't commit it to long-term memory or write it down as a reference somewhere, I will have lost it. So similar in AI, context memory is your short-term memory. This is the ability to say when you feed something to an AI, it remembers the details, can understand and explain. And today that window is very, very short. It's almost like when we started computers, memory in a computer went from, 64K to a meg to 4 meg, 8 meg, 16 meg. And then now today you're talking 32, 64, 128 gigs of memory and RAM. Similar in AI, you're going to see that escalation. And the more and bigger that memory gets, the more things you can feed in AI and the more effective it will be. So we're going to see that grow over time. And the second thing is continuous self-improvement. Today, the way we see models work is that models get trained, then get released, and then you work with that model. But the model never really learns per se. It can reference information, right? Like take the phone number. An AI can quote unquote write it down on a piece of paper, but it can never really commit it to long-term memory until the company decides to retrain that model again and put that phone number inside of that model. But my prediction is as we go forward in the future, you're going to start seeing models self-adapt and self-learn, where in the context, the short-term memory, as it comes in, it can start committing that and retraining itself versus having it to be a manual process a company does. And that's when you'll start seeing learning and self-learning in AI, and that's where you'll see continuous self-improvement. Third, I think you're going to see localized intelligence. So today it's these AIs, these big models. It's ChatGPT, it's Claude. But when you start looking in the future, models are going to get cheaper and faster, and they're going to start being embedded in smaller and smaller things. So it's not necessarily about a big model that you have to go ask questions for. It'll be a model that runs on your cell phone, or a model that runs on your watch, or even an AI model that runs in your toy. Finally, fourth is, this is where you're starting to see action happen really hot now. It's about agents. What are agents? Well, today AI is really mostly used in a creative form. So for example, it's about brainstorming, it's about rewriting, it's about writing, it's about generating images. It's a lot of creativity and about producing content. However, it's not being used in the sense of deciding and acting. And this is where agents come in, where AI can use its reasoning and its logic to start taking actions. So for example, today where you're seeing that played is, oh, well, AI can just go do Google searches for you, or it can go make a phone call to a restaurant to make a reservation. These are small, super minor tasks that you might see an assistant do. But as it starts scaling and getting better, you're going to start seeing AI, let's say, control thousands and thousands of self-driving vehicles and make decisions about that. You might even see AI being in production enterprise software, making decisions around, let's say, a server that goes down and getting it back up, or instantaneously creating new servers and managing a production infrastructure without human intervention. This is when AI becomes very interesting, when it starts deciding and acting, and those are agents. And then finally, I mentioned this a little bit already, but the cost of AI is going to drive lower, and it's going to become way more high performing. So as these chips get super, super cheaper, as it becomes faster and faster, you're going to be able to embed these things with low battery and low energy usage that today could represent a 20-year-old, and then start sticking it in things like robots, drones, other kinds of things that all of a sudden doesn't require a lot of high energy and then can become extremely smart. This is where I think the prediction of AI moves forward. And if all these things are in place, let's talk about some of the things it will enable. So before we get into cybersecurity, we have to see how AI changes the enterprise. Because as we all know, as a cybersecurity individual, we rely on the enterprise. Our job is to protect the enterprise. So first, how is AI going to change the enterprise is then going to affect how it will change our jobs. So let's look at the first part, which is the organization and how it changes. First, all meetings and communication will be analyzed and searchable. This is already happening. I'm sure many of you have already seen the AI note takers in the meetings that you've been in. This is actually a thing that is becoming common. I predicted this a year ago, and for sure this has already happened. Why is that important? It's important because meetings have largely been transient in nature, and if you didn't attend the meeting, then you don't know what really matters in that meeting. Today, if an AI note taker is there, not only will it capture that, but you can query and talk with AI to learn what really happened in that meeting, to take the things that are important where you didn't even have to attend. This makes meetings no longer transient, but permanent. Now, I know all of you who are in cybersecurity are freaking out about this because you're like, I don't want that. That's a lot of IP I've got to figure out how to protect now. However, from a productivity perspective, it does amazing things. Also, because AI is really good at being able to synthesize information and give you the things you really want, one thing that we've always dealt with in enterprise is no one updates documentation. No one actually, we have enterprise wikis, we have all of these portals, but at the end of the day, by the time you write it, it's outdated already. So I predict that AI is going to help us create self-updating documentation and wikis, where no longer does a person have to go in there and say, hey, our new team members are Bob and Jane. AI will recognize it, update it, so that every time you read documentation, it will be up to date. Management status reports. We all love that because how much time do you spend because your boss says, hey, can we get a report on this? I predict AI will start helping generate that automatically. You're going to no longer have to give statuses on those reports. It can look at Jira. It can look at all of these things, pull together all the information that happens in Slack, email, and in meetings, synthesize it into a status report on that project, automatically generated. Wow, now you've just saved, what, 40% of your time instead of writing reports? And then finally, I think AI is going to start becoming local experts, oracles, I call them sort of AI oracles in each area of expertise. So for example, think about AWS. They've already worked on producing this and has already produced this, which is a chatbot that is specialized and an expert in AWS. So no longer do you have to think about, well, what permission acts on another permission in this AWS environment? You can just ask it and it will tell you, and it knows exactly where things are, what they're located, and what impacts and effects it will have because it is an expert in AWS. Similar, I think you'll see that in Salesforce, in cloud, in email, in Jira. They'll all have experts in the area that they're in. And it's interesting to think about, if we go there, how does that change work? All right, the second part, engineering. Engineering is key for us as cybersecurity people. So in engineering, what are the kinds of things that are going to be changed? First, going back to the documentation and wikis, this happens in code as well. So code and cloud will be self-documenting. Already today, and I know those of you who are engineers, AI will document your code way better than you document your code. You can pass it entire repos and it will document that code function by function, feature by feature, and it can keep it up to date. So think about this. Anytime you submit new PRs into your code, it will auto document. It can auto update a new strategy document of what's changed. Everything is automated. You never have to worry about that. Amazing kinds of things. I also think we're going to start getting into more of requirements-driven code generation. So, one of the things that we always do is we always want to have a good design engineering doc on the product that we're going to build. And then you start as an engineer from that set of requirements to go build your product. Well, when code starts being slowly taken away and being done by AI, what's left in the human is almost ensuring that you use AI to help generate the right requirements, twist those and make sure that you tweak them in the right way, and then that is where code ends up being generated. I predict we'll start seeing that already happen. And integrations will become automatic. API to API, how you communicate from one to the other. Feed it the doc, and it can create the code to automatically communicate. That is already happening today. And finally, I think that I mentioned this a little bit in the past slide, but these localized models will start monitoring our systems and remediating them. They'll start self-healing. So if a system goes down, if an application starts becoming buggy, it will recognize these things, can self-restart these apps, and fix the code and problems that happen. This is when things are done at scale. All right, so taking all of that, we've learned a little bit about AI, get some predictions around where AI is going and how that's going to both impact our org and our engineering. Now let's talk about cybersecurity and the problems when this starts becoming a reality that we can now solve. So the first thing we're going to go into is the top security challenges. So this, by the way, for anyone who works in cybersecurity will not be a surprise, but there's not a lot of magic in what the top problems in cybersecurity are. Let's look at the top 6. This is reporting, like, hey, my boss, my CISO, my CEO, my head of engineering, CIO wants to know what's going on. How do we report the risk of our company or the issues and projects that we're dealing with? Vulnerability management, least privilege, third party, compliance measurement, detection and response. This is all standard stuff that continues, by the way, to be the top problems in cybersecurity. So then the question you always want to ask is why? Why are these the top problems when if you go back and look 20 years ago, these were also the top problems? So how can cybersecurity have billions and trillions of dollars invested with so many people, yet the same problems we had 20 years ago are the same problems we have today? Let's take, for example, vulnerability management. Like, is it a problem that because products just can't figure it out? I don't think that's the case. So for example, it's not that the vulnerability management product that you have today is bad. It's just that in order to do the job, it has to be able to solve a problem that's much bigger than it has access to. And what I mean by that is I think that it needs a layer down below that has to do with context. And so what I'm going to talk about here is there's these layers that it's missing that if it had access to, that it could become a way better vulnerability management project, but the technologies never existed. And so let's go into, well, what can AI do to help solve these 6 problems, as an example, vulnerability management, to make it better and to do a job that helps you. So to do that, I think the fundamental underlying layer above these point products that we use to solve is going to be these 3 issues. And what I call them is the 3 C's: coverage, context, and communication. These 3 C's are very much about how to answer problems. So the first thing that we're going to hit is context. So context is the who, what, where, why, and how of everything. So let's take example. How is context going to help us, let's say, do better vulnerability management as an example? Well, let's see how that works. In vulnerability management, let's go through some real scenarios. Whenever a vulnerability management product produces an alert or a vulnerability, here's what happens in a real world scenario. A product produces a critical issue, like, let's just call this an open S3 bucket. The first thing you're going to say is, well, is that really exploitable? Just because you as a vulnerability scanner says it's an open S3 bucket, I don't know if it's exploitable. So if you go through, what an engineer is going to go do is go, oh, wait a minute, this S3 bucket is actually in a dev environment that's only accessible to the dev team. This is not really exploitable. Or you might say, well, are there compensating controls? Well, yeah, that S3 bucket is open, but we actually have firewalls that block the ability to communicate to that S3 bucket anyways. So therefore, it's not a problem we need to worry about. And also, who owns the remediation? Well, just because this thing pops up, I, as an individual, have to go find out, well, who did this and why did they do this? And then how do I remediate this? Who owns the remediation for these things? And I got to go chase down someone in the org in order to do this. So when people say vulnerability management is still a problem, it's because vulnerability management is not just about finding a vulnerability and then looking at the risks and having it centralized. That's only 5% of the problem. The other 95% of the problem is understanding the context of the vulnerability, where it is, who owns it, the who, what, where, why in the organization to chase it down, figure out if it's the right risk or not. All of these things is the 95% of that iceberg that a product cannot solve. And so this is why vulnerability management always continues to be a problem. It's company sensitive, company aware, it's context aware. These are the things that are very hard to automate. So this is a great example of context. And by the way, this applies to anything in security if you think about all of those items. Let's talk about now coverage. Coverage to me is one of the biggest issues in security. It is that coverage to me is defined by width and by depth. So when you think about breaches that occur, for example, if you go look at a lot of breaches that happen in the news, it's always simple things, right? It's always like, oh, it was an open database, or a access key was left open, or an S3 bucket was open, or it was an endpoint that we didn't manage. And you're like, well, what happened there? And it's because the security controls and visibility that we had just didn't cover it. And so there's a width problem of an attack surface that you've got to deal with that is ever changing and ever growing. And there's also a depth problem where there's so much stuff, I never have time to go through it. Like, for example, I may have had a detection team flag an attacker go through things, but the things that they tagged were low alert vulnerabilities that we have thousands and thousands of, and we only have one or two people on the team trying to triage these alerts. I'll never get to the alerts that actually gave the trip of the indicator of the attacker being in our environment. This is an example of depth. Another good example, vulnerability management. How many of you actually go through and assign and ticket and remediate low vulnerabilities? I would precisely say probably 0 of you do this, because you are so overloaded with just the highs or criticals. Getting to mediums and lows is a dream that you'll never have. It's a depth problem of, yeah, I may be alerted to it, yeah, it may exist, but the time and resources to get to it is impossible. So let me give you another example of coverage. Let's take an S3 bucket example. And by the way, this is a real S3 bucket example. So we got an alert that said, hey, there's this open S3 bucket, and it has some customer PII in this bucket. So we're like, really? Where did this come from? And then what we found out is we went, looked at the S3 bucket, and there was customer PI in this S3 bucket. And I was like, well, wait a minute, because in our environment, we have constrained that you cannot even create an S3 bucket without the policies that we've applied. So if you try to make one public, first of all, it's prevented, and you have to get permission from the team in order to make that S3 bucket public. And so where did this come from? And what we end up finding out is sort of this question of, well, what happened here? Oh, it's like, well, actually, this S3 bucket isn't in our environment. What happened is an engineer used their credit card, created an AWS environment, opened up an S3 bucket in order to do a testing between one of our partners to share information to see if it worked in a alpha POC product. Well, what occurred is that S3 bucket never got changed to a production S3 bucket, but when the partnership got established, they continued to use that same S3 bucket, and then all of a sudden it was a production system in our partner, and all of this was getting dumped in this unsecured S3 bucket that was clearly not visible in our environment. This is a coverage problem, right? All of a sudden, it wasn't, they bypassed our prevention, it bypassed our visibility. We had no absolute ability to see that this occurred. This is a great example of now where a vulnerability happens. Now, there's a great example in the same instance about depth. So when our engineers started going through this S3 bucket, which by the way had hundreds and hundreds of thousands of objects in it, it wasn't just customer PII that we identified was in this. We actually identified in its initiation, one of the engineers at the beginning had accidentally uploaded their home directory to this S3 bucket. And in this home directory contained massive amounts of keys that were accessible to very sensitive parts of our organization. And then you're like, oh no, like now you've got to go through and say, okay, we've got to rotate these keys. Did anyone download those keys? Like, how do we monitor the content from these S3 buckets? And it creates a whole series of problems, which is a great example of depth. If one person didn't go through every single one of those objects, we would have considered it just a PII incident and not a key exposure incident that then left the entire enterprise at risk because of it. And so this is a who goes through every single object. This becomes a depth problem. This is where coverage starts becoming really important. There are hundreds of examples of where coverage is problematic. Account takeovers, missing logs and fields, thousands of vulnerabilities that need to be triaged, configuration changes that you don't monitor because you just don't have time or even know it even happens, architecture reviews that your engineers are doing for new features, user and system permissions that are being updated by IT in order to make things easier for employees. All of this is constantly happening in your organization, and you don't have enough eyeballs, technology, and resources to understand what's happening. And this is a great example of why coverage is one of the most critical pieces of what we do in security that today is missing. And let's go to the third C, which is communication. So in communication, I put this as it's the most important thing you can do, but it's also the biggest waste of time. And what I mean that is we all know about how many hours we spend in meetings communicating, how many documents that we write, how many reports that we produce in order to just communicate. It is such a huge waste of time in some sense when someone just needs to look at something so they can say, looks good, let's keep going. But it takes up a lot of time. So when I think about communication, and when you think about what happens today, there's a lot of areas where that occurs. For example, there's human-to-human communication. Those are our meetings. There's system to human, generating reports to see what happens. And finally, there's system to system. Right? Systems are communicating to other systems in order to get things done. And there's always this translation layer in the middle that has to happen. When I generate a report from system to human, I have to translate it so that I can do it human to human. A system to system has to translate from system to human and then from human to human. All of this work happens every single minute of every single day in companies. So these three C's are the critical, I think, underlying layer that is missing from all these products that need to accomplish a task. So if we go to, I kind of gave some examples of communication, but I want to move into what's amazing about this is AI excels in all three of these C's. So let's talk about first coverage as an example. Remember, like AI today is a really smart but somewhat, rebellious, non-street smart 13-year-old. But think about this. If I had 10,000 smart junior security engineers, what would I do with them? Right? And this is where coverage can become really interesting. So for example, I would take one junior security person and say, this S3 bucket, your entire job is to look at every single object that is written to this S3 and determine if it's sensitive or something that we need to be worried about. I would take a junior intern and say, hey, the logs that are going from this system to that system, your entire job is to watch it and see if there's anything that looks sensitive. And if it is, I want you to alert for me. I would take one of those guys and say, I have 10,000 low security vulnerabilities. Your job as security interns is to take each of those low vulnerabilities, determine if it's impactful, where it is, could it lead to a bigger issue, figure it out, and how to resolve it. Like, you have 10,000 of them, you can task them on every little thing that normally you would never be able to do. And you never have to worry about them getting bored in the sense that they're only focused on one thing. This means the coverage aspect, both in width and in depth, you can go so much wider and so much deeper by being able to get that level of analysis done. Let's look at context, one of the most important. With context, I can now help make decisions on behalf of you or give the information you need that you no longer have to manually do. So, for example, in vulnerabilities, it's all about the who, what, where, and why. Well, if AI can go figure that out and answer those questions, it can say, this is a critical vulnerability, but based off of the information we've understood, this looks more like a medium vulnerability, and here's why. Take communication. This is the thing that I think AI is best at. It's all about transforming. So it can take system to human, and automatically generate the things that are the best. You can even human to human it to some way with AI because you can ask it questions. You can take a large report or a meeting and say, what is most relevant to me and my organization and the deliverables that I have in order to be productive that came out of this meeting? And it will help tell you. That communication now can become instantaneous and customized to you as an individual. So how does all of this look in a security product in the future? So I've decided to put some predictions here and give you a view of what I think or what I'd like to see security products change in the future. Let's imagine this world, right, where you are a CISO or a security practitioner. You get your coffee, you come and you sit down, and there is a dashboard and a series of alerts that you need to go look at. So the first thing that we're going to go tackle in this world is detection and least privilege. So what you would get in the old world is you would get an alert that would say, hey, it's an informational alert, a new outbound call was made to stripe.com was identified. This is an atomic alert, and it's informational. And in the old world, or today's world, I like to call it, you would look at this and go, okay, I don't know what that means. Is that bad? Is that good? Is like, how do I even rate whether this is supposed to be a thing I need to worry about? But I think in the new world, when context and communication and coverage can be embedded into technology, I think in your detection product, you'll see something more like this to follow. Oh, but this is expected behavior and is considered low risk for the following reasons. Number one, Stripe is a trusted provider and only outbound calls are allowed. Engineering documentation and discussions have identified that Stripe is a new accepted payment provider because it has monitored both the docs, the product design docs, and the Slack discussions. The Stripe libraries were introduced to this code repo on this date. We know the engineers actually submitted, approved the Stripe libraries to be in their code, and we automatically slacked the Cosmo, who is the active contributor to those Stripe libraries, and asked them, hey, is stripe.com allowed to be outbound? And he confirmed, yes, this is allowed to be outcome. So all of a sudden now, I not only get an alert, but I get the context and the communication around this alert that helps me make my decision better. Oh, this is nothing to worry about. It's a nothing burger. I'm moving on to the next thing. Think about every alert that you've had in your detection could have this kind of context. It would change everything. What about vulnerability management and coverage? So let's take what you get today out of a vulnerability product. Hey, a cross-site scripting issue was identified in this internal system via this commenting function. Okay, is our internal system high risk? Is this something we need to fix right away? Like, I don't know. Well, in tomorrow's world, what we should see is this, which is, oh, it's located here. By the way, this vulnerability only existed for 22 minutes. Oh, that's interesting. What happened? Well, in the activity report, we initially identified this vulnerability via this product. The issue is rated as low risk due to the fact that it's an internal system, limited authenticated users required, and on a staging system. Whoa, that changes everything. Oh, and by the way, at 342, this issue was introduced in the last push to staging. The code that has the vulnerability was found to be introduced by this engineer. We submitted a fix for this PR. Josh was slacked about this fix. He recognized the issue, accepted it. A new rule was added in our code analysis system to make sure we spot this in the future, and this was patched and then deployed. So we now have seen all of the progress of the transformation that has occurred without a single person having to actually do this. And then finally, like when I start thinking about crown jewel alerts, let's say permissioning and how permissioning works, I'm doing, let's say, a least privilege movement in my organization as a mission. And the problem with least privilege is it's very difficult to tell whether someone should have permission to something or not. Here's a great example. Your requested approval settings are high for any crown jewel trust zones. A request for delete access for this role on this S3 bucket, do you approve this? And I'm like, I don't know. Should I approve this? Should I not approve it? It's very difficult to make the decision on approval without context. Well, if AI can provide me the context, it says, oh, our recommendation is to grant access for the following reasons. It was made by a principal engineer who's senior in the company, who is on the team that owns this asset. They actually had meetings and discussions about this specific S3 bucket. And there's a JIRA ticket filed about cleaning this S3 bucket up. And so the requirements document was added. We reached out to the head of security engineering just to get that this should be done, and he gives approval. So you should approve. Oh, absolutely approve. This is sort of the new view of how things like permissioning can be done, which, by the way, is steps and steps above of where we are today. And so reporting. This is also the big waste of time, but is the most important. My least privileged crown jewels dashboard, this is all I want to see. I want to see a list of my crown jewels, my systems, my data source. I want to see percentage of reduction in accounts, reduction in privileges, and I want to be able to see what has been done and what has been changed through an activity log. That allows me to see, hey, we're moving, things are happening, and we are on track to accomplish our objective. Normally, what this would take is asking my people to go generate reports to show me that this is happening. No longer does that have to happen. These things can automate looking at the systems, automate looking at JIRA, automate looking at GitHub, and can look at the documentation and synthesize that information, put it into a dashboard for me that is always self-updating. I never have to worry about it, and my team doesn't have to waste their time pulling together reports in order to make this thing done. So I hope this is the kind of future that I really want to see moving forward. So I also hope that you guys learn some things here around hopefully how AI not only moves in the future and where we hope, but how that AI can really affect our jobs and make our lives easier, not just harder. So thank you for listening to the presentation. Please, if you have comments, I'd love for you to reach out to me on LinkedIn. That's where you find me. By the way, if you connect with me, please send me a message or a note. If I don't know you, I don't accept connections unless you give me a note and say, hey, saw your presentation, then I'll accept the connection. So thank you very much.